Welcome to qnawire.
So here we have this pulley and the block system, and let us suppose that this M1 is 1 kg, M2 is 2 kg, and M3 is 3 kg. These are the masses of these three given blocks. And when the system is released from rest, let us say that M1 strikes to the pulley and the distance it travels is 20 centimeter, that is zero point 0.2 meters. So we need to find out the time taken by this M1 to reach the end of the pulley, or to strike this pulley. We need to figure out that time. So in order to do this, let us first draw the free body diagram and indicating the tension here. Let's say the tension here is T. So here also the tension will be same because it's same along the string. So here the tension will be 2T and here it will be 2T. Now let us draw the free body diagram. So we have this as M1, and the force acting on the M1 we will represent here. Force acting on M2 and M3 will also be represented. So it's clear that on M1 the force acting is 2T, and the weight, because its mass is 1, so it will be 1 into G, that is 10 newtons. And here we consider the value of G to be 10 meters per second squared. Also there will be acceleration. So let's say its acceleration is A1. And now the pulley will also have the acceleration A1 in the downward direction. And we will suppose that M2 has the acceleration as A2, and M3 will also have the acceleration A2. These are the accelerations with reference to a person on the ground. So on M2, what all forces will be acting? Let us indicate that. So there will be a tension force T, and then there will be pseudo force with reference to the pulley moving down. So on M2, there will be force, that is M2 times A1, and the weight will be acting, that will be 2G. Let us take this in terms of G, and later on we will put the value. Similarly on M3, the force acting will be T in the upward direction, and M3 into A1. So M3 is 3, let us put that. So 3 into A1. So here also we'll put this value of M2, that is 2A1, and the weight will be acting, that is 3G. Now these blocks are mulling, they are moving. That means with some acceleration. So we have taken that acceleration to be A2. So let us indicate here A2 and A1. This is also A2 in the downward direction. So observing these free body diagrams and the forces acting on this, from this first mass, the forces acting, we use Newton's second law and we get 2T minus G will be equal to M into A. That means 1 into A1. So it will be A1 only. So let's say this is equation 1. Similarly, we apply Newton's second law to this block M2 and M3 and we get the equation as under for M2. The total force in the upward direction will be 2A1 plus T minus 2G is equal to M2 times A2, that is equal to 2A2. Similarly, so let's say this is equation 2, and similarly we apply Newton's second law to this block M3 and we get 3G minus 3A1 minus T is equal to 3A2. Now we solve these equations, and to do that we multiply equation 2 with 3 and equation 3 with 2. So multiplying this with 3, we get 6A1 plus 3T minus 6G is equal to 6A2. Multiplying equation 3 with 2, we get 6G minus 6A1 minus 2T is equal to 6A2. Now we subtract the equations. We subtract these equations And after subtraction, we get 12a1 minus 60, that is minus 12g, and then 3t plus 2t, that is 5t, and on the right we get it as 0. So from here we can put, instead of t, from equation 1, so we use equation 1 and get the value of t as a1 plus g over 2. So we put this value here, we get 12a1 minus 12g plus 5 into t. So t we got as a1 plus g by 2, a1 plus g by 2, and this is equal to 0. So from here we find a1, we solve for a1. So we get 12a1 minus 12g. So minus 12g, I'll take it to the right, and we get plus 12g, and here 5a1 plus 5g over 2. So we get 24a1 plus 5a1 plus 5g is equal to 24g. So from here we get 29a1 equals 19g, and this gives us the value of a1 as 19g by 29. So if we put the value of g as 10, we get the value of a1 as 190 by 29. Now looking at the pulley and the blocks m1, we have figured out a1, that was 190 by 29, 190 by 29 meters per second square. So it was released from rest. That means with respect to this m1, when the system was released from rest, initial velocity is 0, acceleration we got it as 190 by 29. We need to figure out the time, and the distance it traveled was zero point 0.2 meters. So we use s is equal to ut plus half at square, and we put the values here. So zero point 0.2 is equal to, u is 0, so it will be 0 plus half into the value of acceleration that we found, 190 by 29 into t squared. So from here we figure out the value of t. So after rearrangement we get 2 into zero point 0.2 times 29 over 190 and square root of this. So approximately this comes out to be 0.24 seconds. So this is the time taken for the block M1 to reach to the pulley or to strike the pulley.